Today we are talking about the distributive property. This is Chapter 1, Lesson 4. Okay, so here's where I want you to focus on this concept right here. It says the expressions above, meaning this expression right here and this expression right here, are equivalent expressions because they have the same value, which is 36. We didn't go over this example right now, but all I want you to see is that those two expressions are equivalent, which means that they're equal to each other. This example shows the distributive property. So scrolling down to our key concept here, it says to multiply a sum or a difference by a number, you multiply each term inside of the parentheses by the number on the outside of the parentheses. So here in symbols, you can see right now that A is on the outside of the parentheses. They distribute that A to everything, each of the terms inside of the parentheses, which would be the B and the C. And then over here, that really means multiply. So when you distribute, you are multiplying to each term. So I really get A times B, which is just AB, plus A times C, which is AC. They do the same thing over here on the right for subtraction. So let's take a look at our first example here. We have 5 times the sum of 12 and 4. So remember, I take and I distribute the number on the outside of the parentheses to all of the terms on the inside. When I do that, I know that I'm multiplying, so I really get 5 times 12 plus 5 times 4. 5 times 12 gives me 60, and 5 times 4 gives me 20, and 60 and 20 are 80. Okay, over here on B at the right, again, it doesn't matter now which side that number is on the outside of those parentheses. You're going to distribute it to both terms as long as we're distributing over addition or subtraction. So here I really am left with 20 times 8 minus 3 times 8. And 20 times 8 gives me 0, 1, 6, minus 3 times 8 gives me 24. And so I know that 160 minus 24 gives me 136. All right, so on this page here, we're just going to use the distributive property. Understand that solving this problem, there's more than one way to do it. But because this lesson focuses primarily on distributive property, I want you to use the distributive property and think of how you can set up an equation and then solve for the total cost of the movie. So it says, on a school visit to Washington, D.C., Dishali and his class visited the Smithsonian Air and Space Museum. Tickets to the IMAX movie cost $8.99. Find the total cost for 20 students to see the IMAX movie. So first, let's understand. It says, you know how many students will be attending the movie, which is 20 total students, right? And how much the movie costs. You know that the cost is $8.99. You need to find the total cost for the whole group to see the IMAX movie. So our plan then would be to use the distributive property and use mental math to find the total cost for the movie. To find the total cost mentally, you find 20 times the difference of $9 minus 1 penny. Okay, and then you go ahead and solve. Now, understand again, like I said, I know that most of you know that you can really just take 20 and you can multiply it by $8.99, but because this lesson focuses on the distributive property, I want you to get in the habit of setting up that equation in the distributive form, or that expression, I should say, in the distributive form. So, right now I know that I need to distribute to both of those, and 20 times $9 gives me $180. And I have to subtract that. Well, I guess I'll show you really quick. This is where I'm getting this from. 20 times $9 minus 20 times 1 cent. Like I said, 20 times $9 is 180. And I have to take 180 and 20 times 0.01 gives me 0.2, so 0.20. And I know that 180 in my calculator, if I put it in here, minus 0.2 is going to give me $179, and it's 0.8, but because we are dealing with money, we know that we have to have a digit there in the hundredth place. So total cost for all 20 kids to go to the movie is $179.80. All right, so taking a look, we're going to talk about algebraic expressions now and using that distributive property showing algebra tiles. So right now in this first example on the left, it says the model shows 2 times the sum of x plus 4. So there are 2 groups of x plus 4. We've got 1x here, and we've got 1, 2, 3, 4 here. We've got 2 total groups of those. On the right here, we're going to separate the tiles into 2 separate groups of x and 2 groups of 4. So I've got 2 groups of x here, 1, 2 groups, and then I've got 1, 2, 3, 4, 2 whole groups of 4 over there, which mean the same thing. So the expressions 2 times the sum of x plus 4 and 2x plus 8 are equivalent expressions, because no matter what value that we plug in for x, those expressions are always going to be equivalent. They're always going to be the same. So taking a look down here at my example, it says use the distributive property to write each expression as an equivalent algebraic expression. So once again, I just distribute the outside number to all of the terms inside of the parentheses. So I'm really left with 4 times x plus 4 times 5. And 4 times x really just gives me 4x plus 4 times 5 gives me 20. And because we don't have a value for x right now, I know that those are not like numbers, and I cannot add them together. So 4x plus 20 is the most reduced that answer can get. Again, now I distribute. I have to recognize that a number directly outside of those parentheses is indicating distributive property. I get y times 6 plus 10 times 6. I know that y times 6 is really 6y. Remember that when you are writing and multiplying a variable to a number, that number or that coefficient has to be written first. And I'm adding 10 times 6 gives me 60. And once again, because we do not have like terms, 6y plus 60 is the most reduced that can get. Okay, let's take a look at the last slide here. It says use the distributive property to write each expression as an equivalent algebraic expression. All right, so we've got 3 on the outside, which means we are distributing 3 to both terms inside the parentheses. I get 3 times m minus 3 times 4. And I'm left with 3 times m really is just 3m minus 3 times 4 gives me 12. And because they are not like terms, I cannot combine them or subtract them from one another. So 3m minus 12 is my answer. Over here, I've got a negative 9 that I'm distributing to both terms inside of the parentheses. So I get negative 9 times n. And I am subtracting. Don't forget to carry this guy all the way over here, okay? And just erase that so we've got room to write now. Minus negative 9. Always isolate those negative integers in parentheses, times 7. Well, negative 9 times n gives me negative 9n. And if I subtract negative 9 times 7, that gives me a negative 63. You should be able to recognize now that you have a negative and a negative directly next to each other, which cancel out and makes it positive. So my final answer then would be negative 9n plus 63. Once again, because these are not like terms, I cannot combine them.